Um, Hello, I'm Sahil. I'm a PhD candidate in computer engineering department at Boston University. I'll be talking about my project FLOCX. It's about sharing bare metal hardware, building a marketplace to do that. Um, Today, we either rent computers, machines using either public cloud or we own them here, okay. Or we own them in our own silos. Uh, Public cloud makes sense when your demands are short-term, sporadic, and variable, and it makes sense when your demands cross a certain threshold. It makes economic sense to own your hardware. Um, Even when you own your hardware, there might be events where your peak load exceeds your deployed capacity, and at that time, hybrid clouds can help you. But what about the rest of the days when you have underutilized private hardware sitting in a silo? You still have to pay for the maintenance cost. Can we do something better than this? Can we say share the hardware? So here's the idea, a simple idea that you own your hardware, and when it is underutilized, it is lying idle, you loan it to somebody else who needs it at that time, and then when you need more, you can borrow it back from somebody else. It's simple, right? Not so much. When we talked to these HPC guys, they said, meh, we are not interested in that. Why would we be interested in sharing our hardware? We always run our capacity at 100% capacity. Our demand is usually more than 100%. Why would we be interested in doing this? So I suggested, how about you give 10 nodes in this shared capacity for somebody else to use today, and how about you get, say, 20 or 30 nodes tomorrow? He says, that's an interesting idea, because we don't really care for usage per node. We care for aggregated capacity usage over a period of month. If I come out on the top with extra capacity for my given investment, yes, I'm interested. Then talking to some OpenStack clusters that we host at MGH-PCC with MOC, we realized that they have peak loads which are unpredicted, but they sometimes surpass their deployed capacity. They definitely need extra servers during their peak cycles, but during the slack cycles, their hardware usually stays idle. So they are very happy to participate in such an endeavor where they share during the idle cycles, and they get some sort of comfort that during their peak cycles they will get extra capacity. Talking to the OS researchers, their prime concern was getting exact hardware. I want this exact hardware, and that's why they buy their own hardware, because they are concerned with running repeatedly reproducible deterministic experiments. Their real needs are like 20 to 30 days of usage when there are paper deadlines. Other than that, hardware is usually unused. They would be interested when I suggested that, when we suggested and discussed that the idea is that if we can get the same hardware whenever we want, the one that either I own, or if there is an arrangement where I can get more hardware but exact same hardware in repeated form, then yes, I would be definitely interested in sharing this into the common pool. I interned at the scalability lab of Red Hat, and their peak demand cycles are predictable. They know when their peak demand is going to come up. It's usually around the product cycle when they are releasing products. They do this massive scalable tests to test out their product before releasing it. To put it simply, they spin up an entire cloud to test whether their product works properly or not. That means they need thousands of servers. They would be happy to participate in such a space if they if there is a surety that they can get more nodes to run large-scale tests. Universities here usually have to support these clusters which are very security sensitive, and they have to comply with different compliance regimes like HIPAA. And to set up such clusters, it's usually tedious. So what happens is that people, once they set it up, they leave it them just like that, and they're grossly underutilized or even idle. But as we saw with some of the solutions that were presented today with Bolted and other things, that can be done elastically. And if that can be done elastically, they'll be happy to give up their servers into a share model. Talking to Air Force, we realized that they set up these data centers which are always ready to respond to any national emergency. Now, the nature of national emergency is that they are rare. That means these data centers run largely up to 2% of the utilization over the year. We suggested that how about we pledge you all the hardware in the shared pool. Whenever there is a shared emergency, you can just take it over. Would you be interested in that? And they liked the idea. They said, yeah, that way we do not have to run these massive data centers which do not get utilized. So how do we really make a system which caters to all these divergent, which caters to all these divergence needs? So what are these needs? We need to give a guarantee that people can have their hardware whenever they need. We need to, people who already know when their demands are going to come up should be able to reserve these nodes in future, and people should be able to request specific hardware, like exact hardware, not equivalent hardware, exactly what they want. And there has to be a very strong incentive for people to proactively give up their nodes when either they don't need it, or when somebody else can need more than they do. Basically, we want to reduce the separation anxiety, and we don't want to encourage any server hugging behavior. So how do you do that? Usually, the thing is that when you want somebody to give up what they want, giving appropriate amount of money can do that. We all know from the recent news that's going around. So we thought the solution is building a marketplace with an underlying economic model. The moment we come to this idea that let's have a marketplace, I was very excited. I thought of all these grand concepts that I wanted and the cool features that I wanted to get into this thing. This is going to be my PhD thesis. I thought, I'm going to have trading systems and bids and offers and everything. And then Oran said that, Sahil, let's take a step back. What is the simplest thing you can do? Obviously, his version of simple and my version of simple do not coincide. So, so after a few iterations, we agreed upon certain assumptions that we want for the simplest thing that we want to do. And those assumptions are that the pools of the hardware will be homogeneous, and the marketplace will be able to track the credits for the tenants and the server ownership. That means it can track who owns the server and who is using it or occupying it right now. And to incentivize, we wanted a credit system where people can use these credits to buy extra hardware that they do not own and lease out their own hardware and earn credits over that. Basically, we thought that if we want to encourage people to give up their hardware, we need to have some sort of money or a credit system. So actually, whenever we talk about marketplace, right, what comes to your imagination is a complex systems, right, with a lot of actors and states and everything. It is that complicated, I agree, but building one should not be that complicated. So the simplest thing that we thought is that we will have an extra pool or extra project in Hill, which will be controlled by this microservice FLOCX. FLOCX will be basically another microservice which will be hosted on the top of M2 bolted Hill. And people who want to give up their extra hardware and want to earn some credits out of it will transfer their nodes to this project, and people who want extra nodes will be able to rent it out of this. They will just go and inquire into this pool, look at the hardware that is available for renting, and if they agree with the duration and the price, they can take those nodes and use them. And whatever respective accounting that needs to be done, FLOCX will do it for them. So this microservice, we are calling it FLOCX. So once we have this system in place, what we have with this most simple thing, what we are doing is we are already satisfying the incentive part of it, and we are enabling people to share their hardware. Once this gets running, this gets into production, we would like to build it in layers, is that we can introduce more sophisticated features like the one that I was excited about, right? Having bids, having offers. People should be able to give a price range beyond which they don't want to buy. People should be able to give offers at what time I want to share my hardware, only on weekends, only at night, things like that. People who know that I'm going to need a lot of servers every month should be able to make reservations, priorly, and set up systems where they do not have to pay extra. We can have auctioning systems. There are a lot of other things using dynamic price ranges that when the demand increases, your price will increase, and when the demand falls, price goes down. We can also make this trading of the servers efficient by introducing agents. Initially, users of the particular clusters can decide that when they want to put their nodes for lease and when they want to retract back, and moving forward, we can build agents. Something like some that will optimize for, say, HPC cluster. You want to maximize the CPU usage. So you give more nodes when there is resource contention in the market, and you remove it when it's not there. For OpenStack, you give nodes when it crosses certain price threshold and you earn money. So our long-term goals are we want to deploy FLOCX in a complete MGH PCC and have this economic model where different universities can trade their resources among each other. And we want to build an agile model where we have something quick, fast, live, running. And while we put sophisticated features, we will be able to learn as we go from a production system. In conclusion, we presented some use cases that may benefit from sharing this hardware, and we believe building a marketplace, having an economic model is the right approach to do. I described a simple prototype of how we can get started and get started using quickly. And later, I gave a plan of how we will include this sophisticated features. But I am open for more feedback, more use cases, and different ways of doing things. Thank you.